Shh, 6-2B. Don't forget we have a quiz on Friday on these things. All right, we're going to stick with integrals, but we're going to do integrals and area. So we still don't really know how to solve an integral just yet. We're just getting used to it. We're slowly getting into the pool. Our feet are wet. So lame. Our socks are wet for Jack. He wears socks in the pool. Okay.
Really?
Oh, yeah.
Oh, my.
All right, we're going to find the area under the curve using famous formulas that we already know. Okay? So that's what the integral means. We're going to find the area under the curve. So let's start with one. Let's just get to it. Number one, because I'm not going to go over your area formulas. You know them. We're going to draw a graph and evaluate the integral. Draw a graph and evaluate. Okay, so we're going to integrate from -2 to 2 for the square root of 4 minus x squared dx. Okay. Now, you probably are not sure what that looks like. Maybe you are. I don't know. Maybe you could graph that. But what that is that is the top half of a circle with radius 2. Yeah.
Are we supposed to know that?
No, I'm going to show you why that is. So, do you know a circle with radius 2 looks like this? X squared plus y squared equals r squared. Studied conic sections a long time ago. And if you were to solve for y, you would subtract x squared to the other side. And you would take the plus and minus square root. Well, this is just the positive square root. So it's just the top half of the circle with radius 2. Okay? All right, so let's draw it. Here's -2. There's +2. And so this graph looks like this. It goes all the way up to 2. And if we're integrating from -2 to 2, what we need to do is we need to find the area under the curve between the x-axis and our curve. So we're trying to find the area of that. Exactly. So we're just going to do area equals pi r squared, but we're going to take half of it because it's half of the circle. 1/2 pi r squared for a semicircle. And we know what the radius is. So it's 1/2 pi times 2 squared, which is 4. And so the area would be 2 pi. That's it. Okay? So we integrated. We found the integral from -2 to 2 of this, all this complicated stuff by just finding the area of the semicircle. Pretty rad, right?
Yeah.
Jack, don't use rad? Oh, okay. Here we go. Number 2. Nope. So, all right, now we're going to integrate from 0 to 4 of 2x dx. Okay. So, in order to integrate this, right now, we're going to evaluate the area of it. So, go ahead and draw this, 2x. We should be pretty comfortable with drawing y equals 2x. It's just a straight line. No? Y equals 2x has, what's the intercept? 0. And what's the slope? Good. Rise 2, run 1. So here's the line y equals 2x. And we're integrating from 0 to 4. 0 to 4, right there. Okay? And what does that make? It makes a triangle. Very good. Even Jack knows that. Not you, Jack. My son, Jack. Okay. Whoops. Okay. There you go. It's just the area of a triangle. Okay? And so you use the area formulas that have been instilled in you since geometry. And that would be area equals base times height.
4.
So
Oh, wait, no, it's just a 3.
the base is 4, but what's the height? Well, the height is f of 4, right?
So
8. 8. Do you see that? The height is whatever this y value is when x is 4. So if I take 4 and plug it in over here, I get 8. Pretty good. Okay, so then we get area would equal, what is that? Half of 4 is 2, 2 is 16. Perfect. And so then the integral would then be 16. You integrate from 0 to 4. All right, should we do some harder ones now?
Yes,
Cause, oh, these are just, yeah, way too easy. Okay, let's do number 3. Here we go. We're going to integrate from pi over 2 to 3 pi over 2 for theta d theta. All of that is there just to mess with you, okay? Basically, what this is you could change everything to x's if you wanted to. But usually when we use radians like pi over 2, 3 pi over 2, they use theta. This is just a straight line. It's just the diagonal y equals x, okay? So here's our straight line, or y equals theta in this case. And we're going to integrate from pi over 2, which is somewhere down the road, to 3 pi over 2. So let's talk about what kind of shape that makes. No, what's that called? Is that a trapezoid? I think it is. You know what? It is a triangle on top of a rectangle, and you could do it that way. But that is it's a trapezoid, right? Is that a trapezoid?
The whole triangle and minus.
Oh, the whole thing and minus this little triangle. You could do that. That would be good.
It's about 1/4 like the other.
Yeah. I would do this. I would do 1/2 height times base 1 plus base 2. Because I know the trapezoid formula.
It is a trapezoid?
Yes.
No, that's a triangle.
It's not, Jack. Look at the shape of this thing.
Hey, that's a trapezoid.
Yeah. If you turn it sideways. A trapezoid just has 2 parallel lines. Yeah. No, it's a whole trapezoid. The half comes from because you're like splitting up almost like a rectangle.
Wait, how do you have the height though? Because
Okay. Yeah. So in this case, the height is here. This is the height, and this is B1, and this is B2.
you know that?
Oh, because I know trapezoids. I don't know. I would probably do it your way then.
Can you say that again?
Yeah. You'd get the whole triangle and subtract the little triangle. I'd probably do it that way if I didn't know this one. Yeah, the height of this is really, this right here is the height for a trapezoid. So a trapezoid would be like, here's the height. This is base 1, this is base 2. It's really like that, you know? This is H, B1, B2.
What if it has like that? What's
Yeah, same thing. Height would be, then the height would be the perpendicular. Yep. This already gave us perpendicular. Yeah, you're used to this shape. For a trapezoid, you're used to this. Where you find the height right here. This is base 1, this is base 2. That's what you're used to. But it's missing that part. Yes, you have. You don't remember. Okay, so what is the height, though, in this trapezoid? The height would be 3 pi over 2. Minus pi over 2, right? 3 pi over 2 minus pi over 2, which would be pi. Just pi. You got that already. All right, base 1. Base 1, I'm going to say, is that little green one?
F of 3 pi over 2.
Yes, it's f of pi over 2.
Base 1.
Which is just pi over 2. Okay, the height is always the y value. So it's always to go to your function and plug in the x value, and that'll give you the y value. Remember, y and theta are exactly the same because it's a diagonal. And then B2 would be 3 pi over 2. Now we have all of our numbers here. Let's put it all into the area formula. So the area of this trapezoid is 1/2 times the height, which is pi, times base 1 plus base 2. So pi over 2 plus 3 pi over 2. All right, let's go ahead and simplify this. So I get 1/2 pi times, this is 4 pi over 2, which is 2 pi. So my answer is pi squared. Nice. All right, and like I said, you know, you guys had other ways to do it. Trevor, you saw a triangle and a rectangle, and that would have worked. You would have had to work a little harder for that. Yeah, Sophia saw a big triangle with a little triangle out of it. I think that would have been good. I saw a trapezoid, and because I taught geometry 20 years ago, I remembered the formula. Okay, how about this one? You do this one. I'm going to give you one.
20 years ago.
I did.
I was even born.
Right? That makes me so old. All right, number 4. 0 to 5. It was actually 19 years ago. I'm aging myself. The square root of 25 minus x squared dx. All right, we did one a lot like this at the beginning, but I changed it up just a little bit. Beginning, it was -2 to 2. There was a 4 in there. This is just a semicircle again, but it's not a semicircle. It's a quarter circle, right? Okay, so y equals the square root of 25 minus x squared. If you were to graph that, that would be this right here with a radius of 5. But I'm integrating only, you have to make sure you know what the interval you're integrating on. I'm integrating from 0 to 5. So I'm starting here to there. So the area I'm looking for is just this piece of pie. Would you eat a piece of pie that big?
Yeah.
A quarter of the circle? Polly's cuts their pies into 5 slices.
Oh, did you work there?
I did. Strawberry they cut into 4. I don't know. It's fresh fruit. Fresh fruit pies were always cut in 4s. Okay, so here we go. Now let's find the area is going to be 1/4 of pi r squared. Right? 1/4 this time. All right, so then you get 5 squared is 25/4 pi. You can leave it in terms of pi. Nice. Okay, I've got one more for you. Am I running out of time or are the buses here? Oh, okay. Number 5. Number 5's a little tricky. Ready for it? Here it comes. -1 to 3 for 2x plus 1 dx. Doesn't look tricky. You know, you look at that and you're like, oh, that's just a line, no big deal, -1 to 3. But let me show you what's happening. So let's graph this pretty correctly. So this is just the line y equals 2x plus 1. So our y-intercept is 1, and we're going to count up to and run 1. Down 2 over 1. What would this be? Ew. That's really bad. That's 1/2, isn't it? So at 1/2 it crosses there. Is that right?
Yeah.
Yeah, gross. Yeah, when y is 0, x is -1/2. Oh, gross. Okay. I wasn't lying. Now, I really cared about that point for a reason. Here's my reasoning. I have -1, I have 1, 2, 3. Okay? When I'm integrating, I gotta find the area of this, which is what? Negative. And then I have to find the area of this, which is positive. And then I have to subtract the negative part off. There we go. Nice. Okay? So now I have to find the area of that little rectangle there. So we'll go area of the red one, rectangle. I said rectangle, triangle. Area is 1/2 base times height. Well, what's the base there? The base is only 1/2, right? And then what's the height? The height is when you plug in -1, you get -1, yeah, which is funny. I mean, you can plug in 1, that's fine. And so, but I like plugging in -1 so that you know the area is going to be -1/4. Okay, The area of the blue triangle is a little easier to do. It's 1/2 base times height. What's the base here? It's 3.5, right? 3.5, yeah, so 7/2. And then what's the height? 3 times 2 is 6, plus 1 is 7. You plug it into your function to find out the y value. All right, and so you do that, and you can do it on your calculator if you need to, and it would be 12.25. 12.25. So the area is 12. Total area would be 12. Okay, I think that's it. There was one that had a variable in it, but I'll let you figure it out.